Hi guys! In this video, I will discuss the normal curve. To recall, random variable has two classifications, discrete and continuous. The difference between the two, a discrete variable cannot assume all values between any two given values of the variables, meaning to say, it is finite or countable. On the other hand, a continuous variable can assume all values between any two given values of the variables, meaning it is infinite. And these are examples of continuous variables: heights, weights, temperatures, cholesterol levels, blood pressures, and many more. To define, a normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. So this is an illustration of a normal distribution. So notice the graph here, say continuous. If you notice, no gaps, no holes. Okay? And then symmetric. There is a vertical line here that divides the graph into two equal regions. So this vertical line that divides the graph, this is the location of the mean, median, and mode. Okay? Therefore, it is said that symmetrical about the mean. And then, look at the graph. It looks like a bell. Therefore, it is called a bell-shaped curve or a bell-shaped distribution. Or it is also known as Gaussian distribution because it was named after a German mathematician and physicist, Carl Friedrich Gauss. Okay? And also, back to the graph, if you notice both directions, the graph is getting closer and closer and closer to the x-axis, but it never touches here in the x-axis. It is just asymptotic to the x-axis. Okay? Okay, now let's have the properties of a normal distribution. Number 1, it is a bell-shaped. Number 2, the mean, median, and mode are equal and are located at the center of the distribution. Number 3, a normal distribution is unimodal, meaning it has only one mode. Number 4, the curve is symmetric about the mean. Its shape is the same on both sides of a vertical line passing through the center. Number 5, the curve is continuous. There are no gaps or holes. For each value of x, there is a corresponding value of y. Number 6, the curve never touches the x-axis. Theoretically, no matter how far in either direction the curve extends, it never meets the x-axis. But it gets increasingly closer, or shall we say, asymptotic to the x-axis. 7. The total area under a normal distribution is equal to 1 or 100%. This fact may seem unusual since the curve never touches the x-axis. But one can prove it mathematically by using calculus. 8. The area under the part of a normal curve that lies within one standard deviation of the mean is approximately 68%. Within two standard deviations, it is 95%, and within 3 standard deviations, it is 99.7%. To best illustrate property number 8, okay, so this is the illustration. This is also what we call the empirical rule or the 3 sigma rule or the 68, 95, 99.7 rule. Okay? So this is our normal distribution. Okay, notice the center, it's the mean. And then this is the one standard deviation below the mean and the one standard deviation above the mean. So the one standard deviation is the 68%, and then the 2 standard deviations below the mean and 2 standard deviations above the mean is the 95%, and then the 3 standard deviations below the mean and the 3 standard deviations above the mean is the 99.7%. Okay? Notice it's 99.7, so therefore there is a remaining of 0.3%, correct? And that 0.3% divided by 2 for both ends or directions, that would be used for the outliers. Okay, so let's have an illustrations. Okay, can you spot the similarities and differences? Okay, we have two normal distributions. They have the same means, no? The mean of curve 1 is equal to the mean of curve 2, correct? But they differ in the standard deviations. Okay? So, the standard deviation of curve 1 is greater than the standard deviation of curve 2. So, the higher the standard deviation, the more spread out the data are. No? The less the standard deviation, it is the more compressed the data about the mean. Okay? Next, another two normal distributions, but notice they have the same standard deviation. So therefore, the graph is also the same. The difference is they have different means, right? Okay. Next, oh, so different means and then different standard deviations. Okay? So let's have now an example on how to use the empirical rule and how to sketch a normal curve. Okay. Example. Sketch a normal curve that has a mean of 15 and a standard deviation of 4. On the same x-axis, sketch another normal curve that has a mean of 25 and a standard deviation of 4. Describe the two normal curves. Okay, first thing to do is you're going to sketch a normal curve. Okay, so we have two normal curves and then locate the center, and this would be your mean. Okay, we have the same graph since our standard deviation are equal, no? The standard deviation of curve 1 is equal to the standard deviation of curve 2, which is 4. And then they have different means. The mean here is 15 and the mean in the second curve is 25. To illustrate, okay, now use the empirical rule to get the value of the one standard deviation below the mean and the one standard deviation above the mean. So to get the one standard deviation below the mean, we have to follow this formula, which is mu minus 1 standard deviation. And then the one standard deviation above the mean, the formula is mu or mean plus 1 standard deviation. So in this case, the standard deviation is 4. So 1 times 4 is 4. Then mean is 15. So 15 plus 4, it's 19. So the one standard deviation above the mean is 19. And then the one standard deviation below the mean, the value is 15 minus 4 is 11. So to illustrate, ayan. So this is now your 68% lies within between 11 and 19, no, the 68%, one standard deviation. Okay, how about the 2 standard deviations and the 3 standard deviations. So the same, 2 standard deviations below the mean is mu minus 2 times the standard deviation, and then 2 standard deviations above the mean, mu plus 2 times standard deviation. Therefore, the 2 standard deviations below the mean, the value is 2 times 4, 8. So 15 minus 8 is how much? It is 7. And then mean of 15 plus 8 is 23. So the 2 standard deviation is 7 and 23. And this is the 95% of the data. Okay? That is between 7 to 23. And then the last one is the 3 standard deviations. So 15 minus the rule is 3 times standard deviation. So 3 times 12 3 times 4 is 12. So 15 minus 12 is 3, and then 15 plus 12, it is 27. That's it. So therefore, 99.7% of the data is between 3 and 27. Okay? And to further describe the graph, 50% of the data is below 15, and then 50% of the data is above 15. Okay? The probability that a value will be less than 11 in this direction, no, less than 11 is 16%. How did we obtain the 16%? Notice that above the mean is 50%. And then this is the one standard deviation, which is the 68%. Then half of 68 is 34. So 50% plus 34 is 84%. Therefore, the value less than 11 is only, the probability of the value less than 11 is 16%. Gets? Okay. The probability that a value will be greater than 23, so in this case here, no, greater than 23 is 2.5%. And how did we obtain the 2.5%? Notice that here is the 2 standard deviations, right? And it is 95%. Half of 95% is 47.5%. And then notice that 50% of the data is below 15. So this is below 15, which is 50% plus the 47.5% is 97.5%. So therefore, the probability that a value will be greater than 23 is 2.5%. And then last, the probability that a value will be greater than 27 is 0.15%. Why? It is 0.15% because 27 is the 3 standard deviations, no? Between 3 and 27 is 99.7. So there is a remaining of 0.3%. So divided by 2, because this is divided by into 2, right? So the part here is 0.15 and another 0.15 here. So therefore, the probability is 0.15%. And this area here is used for the outliers. Okay? So, if naguguluhan pa, balikan nyo muli ang illustrations. Master it in preparation for your summative test. Okay? So, that's all. Don't forget to like, share, subscribe, and hit the notification bell for the upcoming videos. Thank you!